Hello everybody, this is Dr. Imran. I am going to present to you another important topic of this course, Electrical Engineering Fundamental, which is Kirchhoff's current law, along with its related examples. This law is a really important law and which has a lot of applications in electrical engineering and in circuit analysis. So let's watch and enjoy. The Kirchhoff's current law. Kirchhoff's current law says that the algebraic sum of all the currents entering or leaving a point is equal to 0. And this is shown by this following expression, that is IA plus IB plus IC is equal to 0. So IA, IB and IC are the currents leaving or entering a point or a node. So let's consider this figure and try to understand about the Kirchhoff's current law further. This is a point or a node and it consists of 4 branches, this one, this one, this one and this one. Across the 2 upper branches, IA and IB are the currents entering to this point or node, while across these 2 lower branches, ID and IC are the currents leaving to this node. So we apply the definition of the Kirchhoff's current law to this circuit, and that is shown by this expression. IA plus IB plus minus IC plus minus ID is equal to 0. We write plus sign with IA and IB currents, while we write negative sign with IC and ID. It is why because IA and IB are the currents entering to this point or node, while IC and ID are the currents leaving to this point or node. The above expression can be written as by the following expression: IA plus IB is equal to IC plus ID, which is another definition of the Kirchhoff's current law. This expression clearly shows that sum of all the currents entering to a point is equal to sum of all the currents leaving to a point or node. IA and IB are the currents entering to this point or node, while IC and ID are the currents leaving. We take an example in order to further understand about the Kirchhoff's current law. Compute IR3 if the voltage source supplies a current of 3 ampere as shown by this figure. Let's try to understand about this circuit. It consists of 2 independent sources. This one is a voltage independent source. This one is a current independent source. As indicated by the example, the voltage source supplies a current of 3 ampere to this circuit across this resistor R1. While this circuit also shows the resistor combination of R1, R2 and R3, 2 ampere is the current flowing across this resistor R2 and I is the current flowing across the resistor R3. In order to further clarify about this circuit, it is redrawn as shown below. I labeled the current IR1, which is the current across the resistor R1, and I also labeled node N, which is common to all the circuit elements as you can see, and I also labeled the reference node and reference. So we apply Kirchhoff's current law on the upper node, and that is shown by this expression: IR1 plus minus 2 plus minus I3 plus 5 is equal to 0. In this expression you can see that I have written plus sign with IR1 and the 5 ampere. It is why because the IR1 and the current of this independent source are the current entering to this node, while I write the minus sign with the current across resistor R2 and the current across the resistor R3, because these are the currents which are leaving to this node. Hence the above expression can be reduced as shown: IR1 minus 2 minus IR3 plus 5 is equal to 0. We already know that the 10 volt source supplies a current of 3 ampere, which is IR1 actually. We put the value of IR1 in the above equation, and hence the above equation can be reduced to this form: 3 minus 2 minus IR3 plus 5 is equal to 0. Hence IR3 can be found as 6 ampere. So you can clearly see from this example that Kirchhoff's current law is so important in the analysis of a circuit having common nodes. We consider another example to understand about the Kirchhoff's current law further. In the given circuit, this one, the 18 volt source delivers 8 ampere of current. Find the value of RA. This one is RA using Kirchhoff current law and Ohm's law. So first we try to understand about this circuit. It consists of two sources, this voltage source and this voltage source. This 18 volts source supplies a current of 8 ampere, while this Vx supplies a current of 13 ampere. We redraw this circuit as shown below. We label the current of the 18 volt source, which is 8 ampere, entering to a node, while we also identified a node here. As you can see, this one is a common node for all the circuit element. We also identify the reference node as shown here. From the figure you can see that the voltage at this node is known, which is 18 volt. Okay, so first we need to find Ix. The Ix can be equal to 18 over 6. 18 is what? 18 is the node voltage here, and 6 is the resistance of this resistance. Ix is equal to 3 ampere using Ohm's law. So once we know about the Ix, then we can apply Kirchhoff current law here at this node, which is shown by this expression. 18 ampere plus 13 minus IRA plus minus Ix is equal to 0. We write plus sign with the 8 ampere current and 13 ampere current. It is why because these are the currents entering to the node, while we use negative sign with IRA and minus Ix. It is why because these are the currents leaving to this node. After solving the above expressions, we can have the current across this resistor RA, which is 18 ampere. Once we know the current across this RA, the resistance of this RA can be shown by using Ohm's law, which is equal to V over IRA. We have the value of the node voltage, which is 18, so we can simply divide it by the value of IRA, and hence we have the value of RA, which is 1 ohm. This is the end of this video. Make sure to subscribe, like and share. Thanks for watching and have a nice day.